Okay. Example 3 is similar to example 1, but oh my gosh, look at our equation. All right, so it's just nasty. It's got all kinds of crazy crap going on, decimals, and it's a polynomial function, degree 3, all that kind of stuff. So doing like we did on example 1 would be time consuming. All right, so we do. Thank goodness we have these amazing calculators. These TI-84 pluses are awesome, and so you do have to do one thing, and we have to have our equation in, and I put it in for y1. All right, so let's make sure I got that right. 1.87, yeah, and I'm using x as my variable rather than t. All right, and everything looks good. Okay, now, so here's the thing. The cool thing is the calculator will allow you to evaluate a function for any value you want. Well, down here on this, what we're needing is, and we can do this one single time and just keep repeating it. This is pretty awesome. So, um, so my average rate of change here, so we'll call it the AROC. That'll be fine. In this case, the average speed, the velocity, all these things are interchangeable. I will equal, all right, the fraction. It's the old school slope, old school slope. So what I need then is, and they called the function d, so I'll use that same notation. D of 8, that's the y, that's y2, minus d of 2, okay. Oh, good. Divided by, let's get that look a little bit better there. 8 minus 2. All right, now here's the cool thing. You're like, oh my gosh, if I had to do that like I did example 1, I'd have to substitute, in this case, 8 in, 3 times, and then 2 in 3 times, subtract those, and over 8 minus 2. Yeah, you would. But check this out. You're going to love it. All right, let's get out of here. Y1 is set. And so let's go alpha F1, make us a pretty fraction. Okay. In the numerator, I want, now remember, this was called y1. Okay, it's not called d like it is in this problem. So we got to use y1. Well, here's how you do it. So if I go back and kick me out of the fraction, go variables, vars, everybody calls it vars, vars, y vars, function, because that's what we're doing, function y1. There we go. And then watch this. If you start a parentheses and you put the 8 right there, that is going to be d of 8. Okay, whatever that is, that's 8 substituted in. But that's not all I want to do. I want to subtract vars, y vars, they're variables. Everybody always says vars. And then start you at parentheses and 2. All right, so that did your y2 minus y1, exactly what we want. And on the bottom, 8 minus 2. Boom. All right, there we are. All right, I did it. All right, so this is, let's do some typing. Go ahead. Oh, there you are. All right, so equal to 63.47, and we got to make sure if they give you units, you need to answer in units. So this is a fraction with our numerator dealing with feet and our denominator dealing with seconds. So it is feet per second. Okay. All right. So here we go. The next one. From 4 to 6. So watch this. Second entry brings back old stuff. Okay. And I need to change. We went from 4 to 6. So this is now 6. I'll type right on top. 4 to 6. 4. Boom. All right, here we go. So I'm back over here. Let's go right in there. This is 48.51 feet per second. Okay. Yay. All right, and then it's like, okay, estimate the instantaneous speed, velocity of the hypercoaster exactly 5. Well, we can't do that yet. We haven't done any calculus that allows us to do that, but we can try to estimate it using values that get very, very close to 5. Okay, so here we go, second entry, and I'm going back up here, and I'm changing this to 5.1. Oh, it's typing on top. All right, so I needed to do the insert thing, but that's okay. I'll fix it. Here, I'll start over. All right, so second entry. All right, and remember we saw this before in example 1, so I should have known. So let's delete that one because we don't want it, and then we want to insert, and it'll insert the 5.1 for us. Keep that parentheses and just scoot everything over. All right, delete that and then insert. Oh, I could have just gone with a 5. All right, that wasn't a big deal. All right, but anyway, but I still did it. All right, so on the bottom is 5.1 minus 5, which I know you know is 0.1. All right, so we could have just typed 0.1, but we had it do it for us. Oh, good. All right, so over here we have 47.3997 feet per second. Okay. All right, and here we go. Let's go to the next one. Second entry. All right, we're back up here. I've got all kinds of parentheses up here I don't need. You go away. Anytime I mess up, I'm just going to leave it, and I'm not editing. All right, so let's delete that 6 that I had previously, or whatever you have now, and I want to insert a 5.01. Should do a good job there, and it sure did. All right, this just needs to be 5. Okay, and then on the bottom, 5.01 minus 5, which you know is 0.01. Okay, and then hit enter. Oh, okay, a little bit smaller. All right, so I got 46 point, and usually it's good to round to 3 decimal places. Okay, you can carry out the whole thing if you want to, but 3 decimal places is the acceptable way to round on AP. So we'll do that this time. All right, and that is feet per second. All right, last one. All right, so on the last one, let's bring that back. Second entry. All right, I love you. And then up here, all right, what I need is that 1 to go away and be replaced by a 0, 1. So I'm going to delete that. Not the whole thing, silly. Wrong delete button. I'm back. All right, so this delete button. All right, so delete that and then insert a 0, 0, 1, right? All right, and then that's just fine the way it is. And then on the bottom, I need that to be gone, or I could have inserted in front of it, you know. But either way you want to do it. And then 0, 0, 1. Everything look good? Sure does. All right, so that puts me at 46 point, I'm around to 3 decimal places, 647. So 647 feet per second. All right, and it says, okay, estimate what you think it might be. I mean, I don't know. I could keep going. We could just try. I'm looking at what she said, 46.647. I don't know, but that sounds okay to me. But I mean, it looks like we would need a couple more to make that kind of determination. But it wouldn't be a bad estimate. So if we said 46.647 is what we're going with, I think that would be just fine. All right. What am I missing? 46.647. Yeah, there we go. All right, sure. As long as, I mean, you can tell it's heading to something. If we did a couple of more rows on that, that probably would, we could get a little more accurate, but for the time being, that'll be fine. Okay. All right. So then it says, explain the meaning of the instantaneous speed in the context of the question. Okay. Well, I mean, and for this question, that is saying that how fast you are going at that particular moment. All right. And we'll talk more about speed and velocity and all that later on. You may know if you've had physics, but for the time being, this is fine. So my explanation then would be, the meaning is how fast okay, I'll say rate of change. The rate of change in the drop of the hyper. I'm going to just be as specific as I can. For hypercoaster, yeah. When t equals 5 is 46 there, 46.647, or approximately, right? So you could say is about. That's a good idea. So I'm going to do that. Is about per second. Yay. All right, boom. All right, so we learned some cool stuff about the calculator, how to deal with the calculator on some complicated calculations that you would have to do, numerous ones if we had to do them by hand. Gross, not doing that. A few more rows there would have been nice, but I guess they were running out of room and they didn't want to do any more. So, but you got the idea. All right.